Assalamu alaikum, sir. This is Mohammad Ridwan Ahmed, ID 2113571, Section A, Batch 34. Today, I will discuss about code vulnerability and compromised software quality. It's a major security threat. After this discussion, we will know what is code quality, code vulnerability, code quality for software security, code analysis, type of code analysis, static code analysis, security issue through code analysis, buffer overflow, and some example. First of all, I will discuss about what is code vulnerability. Code vulnerability refers to a weakness or a flaw in a computer program's code that can be exploited by attackers to compromise the security of the system. These vulnerabilities create opportunities for malicious actors to gain unauthorized access, manipulate data, or disrupt the normal functioning of the software. Code vulnerability can exist in various forms and are often unintentional errors and oversight in this development process. That is code vulnerability. Then I want to discuss about code quality. Code quality refers to the effectiveness, readability, and maintainability of a software product, ensuring it meets functional requirement while minimizing bugs and technical debt. It encompasses best practices, standards, adherence, and efficient problem solving. Then I will discuss about code quality for software security. Actually, every software needs some security, and by code quality, we can assure the software security. Code quality is a paramount for software security, as well as structured, well documented, and bug-free product. Reduces the risk of vulnerabilities, enhancing overall resilience against potential security threats. Rigorous testing and adherence to security best practice further contribute to our robust defense. Then I will discuss about code analysis. Code analysis is the process of reviewing and evaluating source code to ensure compliance with coding standards, identify potential bugs, and improve all software quality. Why need code analysis actually? We need to ensure software quality. Code analysis is the must. Based on increasing customer demand, fast development, and with continuous change in code necessity. Considering the customer demand, every aspect of the software needs to be involved, including the coding methods. This continuous changes in the source code events, vulnerabilities, and risk of defects. This is why code analysis becomes important for any software development cycle to avoid possible product failure and also secure that software product. What does it do? Actually, code analysis is what does it do? Code analysis attempts to debug code to find out code errors or potential code errors of different type, like incorrect function call, memory leak, type casting, security vulnerabilities, code smells, etc. The process of provides an understanding of the code structure, which can help ensure the code area to industry standard and procedure high quality secure code and well managed. Types of code analysis. There are three types of code analysis: static code analysis, dynamic code analysis, code architecture analysis. Static code analysis. What is static code analysis actually? Static code analysis is a method of examining source code for potential errors, security vulnerabilities, and adherence to code standards without executing the program, providing insight into code quality and potential issues early in the development process. It aids in identifying and mitigating issues before runtime, contributing to more robust and secure software. Static analysis flow obtained, source sync, string buffer append, string substring, running sync, sync, static security violation, error categorization of static code analysis, blocker, critical, major, minor information. Different tool for static code analysis. There are 6 different tools for static code analysis: Coverity, SonarQube, Find Bugs, GetAfix, HP45, Inferiority. Security issue through code analysis. Unvalidated input, broken access control, broken authentication and session management, cross-site scripting flaws, buffer overflow, injection flow, improper error handling, insecure data handling, insecure storage, denial of service, insecure configuration management. Example of static analysis. We can give an example of a buffer overflow. It's a critical security risk. First of all, I want to say what is buffer overflow actually. A buffer overflow occurs when an operation that writes data to an allocated buffer exceeds the buffer boundaries, thus the operation access adjacent memory location. Then I give an example, define maximize. Then the get function doesn't allow you to check if the data read to local buffer has less than maximize character. You rely on the sender data to stay within the limit. A malicious user can easily overflow the buffer by extending data generation, then maximize characters and access adjacent region in this step. Severity and impact. Very critical security breach where attackers can manipulate your code. In worst case, they may get the full control of our system. Post bill analysis. The stream variable line 51 could be nullable here. So closing the variable without checking null can throw an expectation. And then line number 46 here, through multiple resources are opened. Line number 46, only once closing finally block. Failure to properly close resource will result in a resource leak. Then the result will not be correct due to missing type of casting. In this example, the expected value is 1.25, where it produced output as 1.0. Pre-built analysis issue. Too many nested condition and loops were used in function body, which makes the function too complex to understand. We can see the screen. Then we can see here a function is defined without adding only code, without adding any codes in function body, line 11 to 13, which meaningless. We can see it also this way. Limitation of static code analysis. large amount of false alarms produced by the software static analysis tools, time consuming while triggered manually, high dependency on programming language performed based on fixed rule sets, no intelligence applied. A typical static analyzer doesn't attempt or propose anything. Scope of code analysis. Difficulties or limitations often open the doors of opportunity, no expectation here as well. Improve the accuracy of the static analyzers by reducing false alarms. Integrate the analyzers with the auto-build continuous integration system. Inclusion of AI-based intelligent analysis techniques. Auto fix with high accuracy is the future of software quality through static analysis. Finally, focusing on software quality security can create a great positive impacts on IT industry as a whole. Thank you, sir. Assalamu alaikum.